Hi, and welcome to my YouTube channel. I'm David Anderson, and today I'm going to show you how to implement a simple three-layer architecture in C# and .NET. It's been a while since I've done some videos, and we're going to do a little bit differently this go-round. We're not going to focus so much on the typing of code as we go along. We're not going to focus on a specific UI framework, so we're going to use actually a ASP.NET Core console app when we get to the code. It's kind of late at night, and I haven't done a video in a while, so I said, what the hell? Let's throw one together and get that out there. So I've been studying architecture quite a bit over the past 10 years, and I've implemented various ones. And we're going to go all the way back to basics in this video. So with that said, let's kind of dive into the details a little bit. So we are going to, this is the architecture diagram I threw together. So we're going to have a SQL Server database as our storage provider. We're going to have a data layer on top of that. With Entity Framework Core, so our typical DB context. We're going to have a data context provider, and we'll get to that once we look at code and show you why that's important for this design. We're going to have a business layer we're going to throw on top of that data layer with some kind of aggregate route. We'll explain what that is here in a minute. Business entity and active record. Those will be the three kind of key players and the business layer. And then ultimately we'll tie all that together in the console app, which will serve as our presentation layer. So this is a three-layer architecture data business presentation on one physical tier. We're going to do this with an active record-based design. So like I said, we're going to go back to basics, keep it simple, and I'll do other videos on other types of architectures and designs in the future, but I wanted to just start with this because I implemented this recently in a CRUD-based enterprise application. Just a reminder, layers and tiers are not the same thing. You use layers to organize code into different areas of your project structure, especially in terms of testability and maintainability of your code base, while tiers are where your code physically runs, whether I have a client tier on the desktop or I have a server tier with a web API set of web services running under IIS. This is not going to be domain-driven design or command query responsibility separation, transaction script, or any of these other types of designs or anti-designs, whatever you want to call them. But this is going to be a domain model. So we're going to provide both state and behavior. So we'll have properties, we'll have methods that enact business logic. And I will say that in this particular case with Active Record, it might be best used in a data-driven application where business logic is simple. You can implement complex business logic, but I also did write a blog post on my experience doing that in an enterprise application. So you can, I'll put that link in the description, and you can see that there. It's kind of a full walkthrough of my thought process, the decision-making that went into it, and some of the challenges that we had. And just a quick mention, I'm not going to do any of this in the video because I don't want to distract from the overall design, but this will be testable with a little bit of work. Entity Framework Core provides in-memory databases. If you're not using EF Core, you can abstract away your data access layer through an interface. There's a lot of different ways you can implement testability into this. And going back to that blog post, just as a use case, like I said, I implemented this over the past 6 months to a year in a larger enterprise application in the banking domain. And it is currently very stable and very successful with about 3,000 unit tests as part of that framework. And that probably represents maybe 5 to 10% of the business logic for that application. It started out as a large ASP app, and it's kind of migrating to some different technologies over time. So much more complicated architecture. What we're going to do today is much more of a simplified implementation of that. So Active Record, just to follow up on that, we're going to encapsulate a single row data. As Martin Fowler says, single row data, but adding domain logic to that data. So Active Record will be responsible for persistence. I'm going to load, create, and save that row of data within the active record. And an important key point of that is that you should have that persistence isolated. So one active record should not affect another. If you really don't truly have a active record class at that point. So a business entity is an active record and will derive from it and will basically implement the business logic on top of that data access and will enforce the validation, the business rules, and the business processes. And we are going to kind of talking about domain model. Domain-driven design is a very popular methodology for building software, especially large software. Conceptually from that, we are going to model the domain, but the limitation will be that we are tying this business entity to a row of data. So we are technically constraining ourselves somewhat to the data storage structure and not fully to the business domain. So there is a distinct difference in this architecture from something like domain-driven design, where your business entities have no concept of persistence. So you can design those to truly model the business domain. This is best if you have an existing database, this is sometimes easier because you can create brand new business entities that map one-to-one to the existing database tables. Or if you're building a new application that's very CRUD heavy and it naturally fits that one-to-one mapping, this architecture might be a really good fit for that type of application. But for something where business rules are a little bit more complicated, this might not be the right architecture. So the third conceptual piece in the business layer we're going to have is an aggregate route, composite route, domain service, business component, whatever you want to call it. But we're going to provide an entry point to the business logic. This will essentially be what ties some of the business operations together. And these types of classes don't have their own persistence. They're not a business entity in of itself, but it will tie them together. Okay. So let's take a look at some code. So what we're going to do is we're going to start with the bottom layer and work our way up. But before we do that, I'll give you a brief kind of overview of the project we're going to be working with. So first off, we have 4 projects here. The database project I'm just going to provide so you can download the sample code and create the correct schema to work with. This will be a live program you can run and actually work. Use it that way. We have a business project to isolate our business layer and a data project to isolate entity framework and all of our data access classes. And then the presentation layer, which is just a ASP.NET Core console application. So I don't want to get too hung up on UI frameworks and UI technologies. And as we do this, the business classes, I'm just doing something basic. I don't want to get hung up on specific domain areas like banking or in this case I'm using software development, but we're not going to get too in depth with that. We're going to focus primarily on just the architecture aspect of things. Another reminder is that in architecture, it's not always fair to say that your layers will be an individual project. You may have them spread over multiple projects or even multiple namespaces in your application. But in simple applications, it's easy enough to separate them into individual projects. So our presentation layer is just a simple console app that's going to take some commands in. We're going to be able to do things with our business objects, like basically get a list of developers, for example, and add work items and that sort of thing. So there's really not a whole lot to the presentation layer, but we're going to work ourselves bottom up from the database. So the database structure itself is pretty simple, and there's an important reason why I decided to name this table person rather than developer. I want to demonstrate to you that your business objects don't necessarily need to reflect the underlying data storage. So our business object we're going to be working with today is actually going to be a developer and a organization and a work item. The underlying data storage is a person. Persons have roles, and then we have the work items associated with that. And you'll notice that there is no organization. We're going to use the organization as an example of an aggregate route that ties all this together. So there's not much else to say about the database itself. So let's start in the data access layer, and let's actually look at the foundation of all of this, which is kind of entity framework is the next step up. So again, we have our DB context implementation. This is, again, Entity Framework Core, so this looks a little bit different than EF6. But basically the same thing, your DB sets and your entity classes for the tables and all that. So we are using code first. So we are using data annotations to map the entity to the underlying data schema. So all of that is just your typical ORM functionality. We have iData Context Provider. This is going to be a key interface in really facilitating active record as part of the architecture holistically. And we'll actually show you that now, which is in our active record class. So this is the heart of this design. So we have an active record, and there's probably 1 to 50 different ways to design an active record class. There's also active record frameworks out there you can use as well if you don't want to build your own. But we basically have an active record that is going to encapsulate a certain kind of entity from our entity framework mappings. So it might encapsulate a person or a work item or a person role, but that is what T-entity does for us. And T-key will basically be the primary key. This is important because if you have a compound primary key where it consists of 2 columns, or you need to change the primary key in a certain instance from an integer to a GUID or something different, we want to have the flexibility to do that. And then just some basic constraints that we need to be able to create new instances with these generics. iData Context Provider is how we're going to basically make this class testable, and also how we're going to ensure that each active record has its own instance of our data context. And that's important going back to how an active record should not affect another active record. We want to make sure that it gets its very own instance of the context. So when we make a change and save it, it doesn't accidentally save pending changes on other entities that Entity Framework is tracking changes on. So that's kind of what that guy does for us. Here's our primary key property, T-key. And then our basic active record functionality of loading an entity based on that ID. And our default implementation, we're just going to use the find method that Entity Framework provides. If we do find one, we're going to set the key. If not, we'll just throw an exception. I will mention that this project is not intended to be a completely polished example, but more of a quick start to get you going. Our new function, which will basically be what the developer uses to indicate they want to create a new active record in the database. So we just create a new instance of that and add that to the context. Delete, pretty straightforward there. And then ultimately our call to save changes. Now what's interesting here is I've made a call to save changes in delete, because deleting it's almost like save. It's a direct action that should happen right away. We don't, at least as far as how I've designed it, I didn't want to have to call delete and then save. It kind of seems counterintuitive. But the other functions like new, I'm going to create that record, but I'm not ready to save it yet because I might need to set some values and then I need to call save. So that's kind of the thought process behind that, but you might want to decide to design yours a little bit differently. So active record as a base is pretty straightforward at this point. Let's go take a look now at our business layer. So we've wrapped up pretty much the whole premise of the data access layer. Our business layer now is going to introduce business entity, which we said in the PowerPoint slide there that it is a active record, so it derives from it. Same constraints, same dependency injection for our data context provider, but now we're adding on top of that data access and persistence, now business domain support, validation, essentially is the primary thing that a business entity as a base class will need to provide. So we are using data annotations to do that. We've got our isValid function, which will return a out parameter of validation results. And in the newer versions of the C# language, these can be ignored with a special operator syntax, which is kind of cool. And then our save method will make sure that it calls the validation functionality if the developer doesn't do, just to protect the underlying data from malicious data or incomplete data, things like that, or bad state. And then we provide, lastly, a way to plug in custom validation logic that might not be adequate, where data annotation attributes might not be adequate. And so those combinations of validation, there's our data annotation validation, and then the second call to our custom validation on validate. So now we can start looking at our business entities. We have two of them. We have a developer and we have a work item. Now, a developer obviously is a person. So this is kind of what we're talking about, how the business or the domain model is not the same as the storage model. We don't have a person class in this case, but that is how it's stored. That's the type of entity, and then it has an integer primary key. When we're designing business entities, especially in Active Record, or even just in any really domain model type of design, a lot of the properties are going to end up being read-only. And the reason for that is a lot of times it's going to be information you need to get and display or use in the software, but to change that information might be some kind of actual business action that needs to be encapsulated into a function. So changing an email address is not necessarily as simple as saying, I'm going to set the email on the property. I might want to validate that no other user has that email set. I might want to send a confirmation email. And so we're going to provide the email as readable information on our object, but we're going to provide a change email function that can encapsulate all the other domain logic that has to go with it. So when you're designing a business entity, that's as far as how I do it, that's kind of the thought process there. I don't have all the different functions for this, of course, but just as some examples, we have a developer who has a name and email. We have a role. We have a number of work items assigned to the developer. The work remaining, which would be the number of hours, and we could be more specific and name it hours remaining. And then now we have actual business logic. So adding a work item, and then we have our actual work item business entity as a parameter. And you'll notice that in here, there's really not a lot of data access logic. We're actually delegating some work here, and we'll look at that in a second. But then we come down to get work items, and now we're accessing the data context. We're not changing any information. We're not saving anything. We're not affecting any other active records, but we are returning related data. And so this is an important note where I did not add a property, i.e. enumerable of work items. And the reason being is, at least in terms of the active record design, loading that information would mean that it's no longer an active record. It's now some kind of aggregate route, which you would hear more about in domain-driven design. It's not just that single row of data anymore. And if I were to add that as a property, you would have design problems like, when I save this developer business entity, what do I do with that list of work items? And now you also have to manage the state for that list of work items that's on the developer object. If you add or remove work items, keeping that in sync with the database, there's design issues with doing that with the active record pattern. So instead, when you're working with related data, we access that via methods or business operations that can be performed, and each one of those other business entities, being an active record, can then be loaded and returned to the caller. And now you're working with each type of active record individually. So in this case, we do get a list of IDs from the database, and then we create instances of those work item active records, and we load them and then return those to the caller. And so in most cases, this design will be pervasive in your business layer, and it will be pretty rare that you ever actually have to call the load function within your presentation layer as you're consuming your business layer. It really will be more internal to your business entities, how you're accessing those related records. The yielding is really nice in this case because since active records are not loaded in mass, there's no batch It is a performance trade-off, but being able to return those one at a time and allowing the caller to break the loop early and not load everything is a nice advantage that you have there. So working with related data, state, now we have kind of some more of the persistence. We have the load functionality, which, basically we have our base load where Entity Framework finds the entity and stores that in that object. Just to kind of look at that one more time, basically our protected entity member of the class. And then this is where now we have the opportunity to load information into our properties of this business object in our load function. And this is also where now you might be able to access some of the other database tables to get information you need, especially maybe doing some aggregates, some calculations or things like that. We're still not affecting other rows in the database, but this is normal in terms of designing a domain model. So pretty basic there for our developer class. We can add a work item, get work items, and then just some read-only information. A work item itself, if you notice back on the developer, if we add a work item, we basically indicate which work item we're adding, and we're actually delegating the work to the work items assigned to method. And so this is where your interaction between active records becomes important. We're not affecting any persistence in this case. So if we go look at our work item, and here's an example of using data annotations for some validation. And really quick, this is an example on this description property where not making it read-only is acceptable because there's no other business behavior that has to occur when changing the description. It doesn't have to be unique. It's a simple piece of validation, just saying I need it to be required. I don't need to send an email or do any kind of other business operations. So in those cases, it's okay to expose things as read and write properties. So here we get to our assign to function on the work item. So in this case, the business logic is as simple as just assigning the underlying entity's person ID to the ID of the developer business entity. And so one important thing I'll mention here is that in a architecture like this using active record, you do not want to expose your database through the business entities other than the primary key, which is your means of uniquely identifying that active record in your code. So everything else should be exposed in some fashion that the business can be understood, instead of a priority ID or a navigation property, which we talked about that and why we're doing that in functions rather than properties. We're actually storing the name of the property. And then some more business behavior. We can change the status of a work item. And again, at this point, we're not actually persisting anything yet. That's going to happen when the developer calls the save method of the active record. But we can manipulate the underlying entity as much as we want at this point until we get to that point where we're ready to make that save call. So the same thing for priority. In this case, we're just taking the actual names of the values, which in the business domain would be unique. We don't need a separate business entity for a priority itself. It's just a value. Same thing with like doing estimations and then log work. Here's an example of some simple calculations, some business logic there. And then ultimately load. Here's a little bit better of an example than the developer class, loading quite a few more properties here. Here's an example of new where we want to create the default record, but then we want to assign some default values to it. So in this case, just keep it simple. We're doing the first status or first priority, and we actually, a little bug there. First records we find in the database, just for brevity. Saving, now here we have an example of how once we are ready to persist the information, we're assigning that to the underlying entity, and then we actually make that persistence. And then once we, like in this case, if we know that it's a ID of 0, meaning that it doesn't have a primary key quite yet, after it's created by Entity Framework Core and SQL Server, we can take that and now assign it back to our business entities so that can be used once the entity is persisted. So business entities should typically look like this. They're, at least in this case, they're lightweight. Business logic is very granular. It definitely models the problem domain very well. How you design the business logic is completely up to you. Business layers are often more free-form than anything else because you can model a problem domain in one of many different ways. But I am an advocate of what people do in the domain-driven design methodology, which is your business entities should reflect that problem domain to the best of your ability using a ubiquitous language that everybody can understand and agree upon. So that is our business entity, the two of them that we have. Now let's go look at our aggregate route. You might call it a composite route, an aggregate route. In DDD, this would be considered maybe even a domain service, whatever you want to call it. This is our class that's going to tie some of our business logic together, provide that entry point. It doesn't have any persistence of its own, but it will use the data access layer to tie things together. So in this case, we have a basic, I need to get access to a developer by their email, or I need to get a list of developers. And this is where we kind of tie some of these pieces together and essentially return either a list of developers or an individual that we can find in the database. So pretty straightforward. As you can see, like I said earlier, this will be pervasive through the architecture. So we can take a look at the presentation layer. And so, like I said, this is a .NET Core console application. So you can kind of ignore some of the specifics, but we have our connection string and the app settings JSON file. We have the implementation of the data context provider. And this is important because when you have a layered architecture, you need to design it in a way that's platform agnostic. And what I mean by that is your data layer and your business layer should not have any code or any indication on the platform that it's going to run on. And so you might provide interfaces, like in this case, our data layer provides this guy, but the implementation of that and how to provide a data context, which also means it's going to know how to find the connection string, really belongs in your actual application, because I might reuse the architecture in a desktop app and a web app, and they have my desktop app might have a app config on a local, well, obviously in the application folder, whereas a web app might store the connection string in a different way, and so on and so forth. And so that kind of services or interfaces, that's what I call the bridge between the platforms. That's very important. So the console app is pretty simple. Like I said, it's a loop of commands. So we take in the command. There's a simple little command parser, and it basically just uses reflection. So whatever the name of the command you type in, it tries to find the corresponding command in the commands folder, or based on the types in the assembly, rather. So pretty straightforward. And if it finds one, it'll execute it. If it doesn't, you get an invalid command message. And so we've got our command-based class, which is the command pattern, where we have an execute method that gets implemented, the identifier, which is the actual name of the command. And then we do, in this case, want to pass in our data context provider, because in the presentation layer, this is how we're going to tie the presentation to the business layer and get those dependencies passed in. So our first command is, CLS is just to clear the console, nothing crazy, is get work. And so what this does is we create a new instance of our organization. We pass in our provider to that class. And then now we're tying into the rest of the business layer but there's no business logic in here. This is purely presentation logic at this point. So now you've seen the clear separation of concerns. The data access entity framework provides us the query generation, the ORM mapping and all of that. The business layer provides the actual business logic, and the presentation layer provides just presentation and interaction to the end user of the application. And so if we were to run this to just kind of show you what this looks like, very simple. So I can say get work. And what that's going to do is kind of create our organization class, get developers, load up developer active records or business entities, and start calling into all those APIs. So now here's our work items that came from there. We can also add a work item. And so, we have a art architecture. That's who we're going to add this for. And I'll show you an example of the business layer doing what it needs to do, which is validation. If I don't type a value, we actually are able to call into the isValid method when that fires. So we take in all our information, create an organization. We get the developer based on the email that was provided. If one wasn't found, we present that to the end user. If we do find one, then at that point we can create a new work item. There's our active record syntax there. We set some values and then assign it to the developer. And so at this point, then we can check, this is an example using some validation before we try and save, so we can display the appropriate message to the user. So if I were to come back in here, there's our validation messages. So let's go ahead and fire that again. We can do a couple different things. And let's just do, business layer does not have an API deleted work item. And so I add that, and we can see here that we've added that to that particular developer. And so now if I were to call get items again, or get work rather, now we can see that we have our new work item with an ID of 1006 added to our developer. So that's the most simple example I kind of threw together of tying the three different layers together without getting too hung up on the presentation layer. I've done a lot of WPF and MVVM videos, and my main focus lately has been Telerik's Kendo and MVVM and ASP.NET Core. But pretty simple little architecture, very powerful. Like I say, I recommend it for simple applications, but you really could build more complicated business layer with this, but you do start to run into technical issues where you need more business entities to be aggregate routes themselves if you have complicated business logic. But for applications where it's very data driven, as in the application I implemented it in, which was larger, the database was already there at about 150 or so database tables. And it was kind of the developers who wrote it designed from the database first. So this was a natural fit to that existing application, and coming from an older technology like classic ASP, we were able to write this brand new infrastructure over time, and eventually it'll just migrate naturally as we write more code. So that's kind of the architecture I had prepared. Pros and cons and challenges, like I said, you can go out to my blog post I linked. I kind of explained the whole process there. The one main thing I realized is, performance is a trade-off. It always is. But you should never really design for performance unless that's a critical thing. You should optimize as you need to. And so with Active Record, you end up basically having a lot of micro queries. You're accessing the database many, many times, but they're very, very small individual queries. I need to go get a list of work items. I need to load a developer. I need to add a work item. And everything you do is very, very small and granular. Whereas in a larger application like domain-driven design, these aggregate routes, you might do things more in mass because your business logic is more complicated. You might have batch updates and things like that. So Active Record can't facilitate that for you, right? Active Record, you're always doing kind of microtransactions to the database. But in most applications, when you're doing units of work, I'm filling out a form or I'm listing out a grid of data or generating a report, you're always typically doing a unit of work and you don't need those complicated scenarios. And then, you can also build separate high performance APIs in addition to your Active Record classes. Downside, now you might have duplicated business logic, but the plus side is you have really nice APIs, a really nice domain model for the 90+% scenario of your application, and then you have high performant APIs. Yeah, it's a little more work to maintain the duplicate business logic, but for that last 10% of high performance scenarios, you have those APIs. So in every architecture, you're going to have trade-offs. If you design domain-driven design, sometimes it's a hell of a lot of work to build business entities and things like that, aggregate routes for simple business logic. But in the end, if your application warrants that, it's the way to go. I've found in my experience, I've done all kinds of different architectures. It just really depends on the needs of your application. But I've found that most like web applications typically are very just CRUD heavy, forms, reports, grids, profiles, all that kind of stuff. So performance is one consideration you should take with this. I also chose, this architecture is also good for teams that have maybe a slower ability to adopt design patterns and architecture. It's simple, it's easy to learn, and it's also quick. You can develop like this little demo we put together, I threw together in about an hour. And so, versus something like domain-driven design has a very high cost, but a long-term payoff. Active Record, you can get both, but more so you definitely have a more rapid type of development with Active Record. So lots of trade-offs. Read my blog post. I kind of list them all out there and let me know what you think. Thanks for watching.